Hello everyone, welcome again to Emmanuel Educational Center. Please like this video and subscribe to our channel for more educational content.
Deducing protons, neutrons, and electrons. Finding the protons. The atomic number of an atom and ion determines which element it is. Therefore, all atoms and ions of the same element have the same number of protons in the nucleus. E.g., lithium has an atomic number of 3. That's 3 protons, whereas beryllium has atomic number of 4. That's 4 protons. The number of protons equals the atomic number. The number of protons of an unknown element can be calculated by using its mass number and number of neutrons. Mass number equals number of protons plus number of neutrons, and number of protons equals mass number minus number of neutrons. Finding the electrons. An atom is neutral and therefore has the same number of protons and electrons. Finding the neutrons. The mass and atomic numbers can be used to find the number of neutrons in ions and atoms. Number of neutrons equals mass number minus number of protons. Electronic configuration. We can represent the structure of the atom in 2 ways, using diagrams called electron shell diagrams or by writing out a special notation called the electronic configuration, or electronic structure, or electron distribution. Electron shell diagrams. Electrons orbit the nucleus in shells or energy levels, and each shell has a different amount of energy associated with it. The further away from the nucleus, the more energy a shell has. Electrons fill the shell closest to the nucleus. When a shell becomes full of electrons, additional electrons have to be added to the next shell. The first shell can hold 2 electrons. The second shell can hold 8 electrons. For this course, a simplified model is used that suggests that the third shell can hold 8 electrons. For the first 20 elements, once the third shell has 8 electrons, the fourth shell begins to fill. The outermost shell of an atom is called the valence shell, and an atom is much more stable if it can manage to completely fill this shell with electrons. Rules of electron shell filling. The arrangement of electrons in shells can also be explained using numbers. Instead of drawing electron shell diagrams, the number of electrons in each electron shell can be written down, separated by commas. This notation is called the electronic configuration or electronic structure. E.g., carbon has 6 electrons, 2 in the first shell and 4 in the second shell. Its electronic configuration is 2, 4. Electronic configurations can also be written for ions. E.g., a sodium atom has 11 electrons. A sodium ion has lost 1 electron, therefore has 10 electrons. 2 in the first shell and 8 in the second shell. Its electronic configuration is 2, 8. Electron shells and the periodic table. There is a clear relationship between the electronic configuration and how the periodic table is designed. The number of notations in the electronic configuration will show the number of occupied shells of electrons the atom has, showing the period in which that element is in. The last notation shows the number of outer electrons the atom has, showing the group that element is in. For elements in groups I to 7, elements in the same group have the same number of outer shell electrons. For example, the electronic configuration of chlorine is 2, 8, 7. A chlorine atom has 3 occupied shells of electrons, so it is in period 3. Group. The final notation, which is 7 in the example, shows that a chlorine atom has 7 outer electrons and is in group 7. In most atoms, the outermost shell is not full, and therefore these atoms react with other atoms in order to achieve a full outer shell of electrons, which would make them more stable. In some cases, atoms lose electrons to entirely empty this shell so that the next shell below becomes a full outer shell. All elements wish to fill their outer shells with electrons, as this is a much more stable configuration. The noble gases. The atoms of the group 8 elements, the noble gases, all have a full outer shell of electrons. Therefore, all of the noble gases are unreactive as they have full outer shells and are thus very stable.